Okay. So what we covered in the last class, in yesterday's class.
Topologies.
Mm-hmm. Okay.
Types of topologies. Transmission point to point. First topology.
One by one. You are not there. Okay. Yeah, before that, did everybody got the drive access? Everybody? Yes, online?
Yep.
And Gopal Krishna? Mr. Gopal Krishna, are you there? Okay. So in that, what folders you found? One software folder is there. Okay. One documents. Okay, in that document you can find the study material. Okay. And this whatever I teach, I'll share it later. Done. So if I do it now only, then it'll be gone. Okay. And then the videos, in that video file, you will get the daily recorded video. Okay. Just you can watch it later. Yes. And then one more is that WhatsApp link, right? Okay. I hope you all joined through that link. Yes. Okay. Then. Yes.
Types of topology. Point to point topology. First topology. And ring topology. And,
We covered only topologies. Huh?
Types of topology.
Okay. Started with topology. Started with topology. Okay. Then
Types of network.
mm-hmm.
Topology network.
Mm-hmm.
LAN, WAN, MAN. CAN. MAN.
Okay.
And
Then
median, transmission median. Guided and unguided.
Okay.
So we started with the types of networks and we discussed about the mediums of the transmission and then we discussed about the topologies, topology discussion.
So in that case, what is EPN? Enterprise Area Network. EPN. Uh-huh.
It is used for is controlled by one organization to control the network.
Okay.
To connect in different
Organization.
Different nodes are.
Okay. Yes, Bharati. What is VPN?
Which one is
VPN.
which is
Yes. Virtual private network. Yeah. What is that?
The virtual private network is a type of a computer network that extends the private network to the internet, as it can use to send and receive the data through virtual point-to-point connection. User can access the servers and devices and and it can form the point-to-point connects virtual point-to-point connection over the private network.
For the private network.
It
Colon. SAN. Storage area network.
It is used the storage the network that the user can access later.
Okay. System area network. Yeah, nobody's there.
So we can type of network to connect the devices in the networks so that users can share and receive the resources.
We'll do one thing. Get up. Close that door. Okay, what is WLAN? Somebody? Wireless local area network. Okay. Why it is used?
Connect to local
Just to connect all the devices locally without any media, physical media. Okay, that is all about wireless. What about next one? Storage area network. What is a storage area network? You can see this kind of network in data centers, both storage network and system area network. These are high-speed data transmission network, okay, where you can find storage devices just like the servers. And to maintain these devices, whatever the system will be having, whatever the network will be having, that we call it as a system area network. Okay, and after that we had colon. Okay, so this is kind of a network where we use this fiber optic cable. Okay, and after that we had enterprise network. Okay, it will be in a single organization, so that will be controlled by a single organization just to maintain their network operations. Okay, and after that we have VPN. Okay, it's kind of a private network over a public network in simple words. Okay, if you want to make the communication between two private organization, okay, so we have only one way. Okay, in a secure way. Yes, what we can do? Either we can go for a secure way from laying cable from one organization to other organization. Okay, but that's a cost effective. Understood. So that's the reason we'll use the whatever currently what we are using, that is the internet. Okay, and internet is not that secure. Yes, but still what we'll do, we'll create a tunnel between these two organization or two locations, I can say. Yes. So this is called as what? Virtual private network. Yes, and after that we have VLAN. Okay, here okay, I'll explain it later because we have a separate this is a separate protocol in switching. So after this, immediately we're going to learn that one. Okay. So I mean, the VLAN is what we are going to segment the single broadcast domain into some multiple broadcast domain. So that's it. Okay. So these are also some different types of the network. Okay. So today we're gonna start discussion about the start the class with the different networking devices. Okay. Yesterday we are seeing some basic part of the network. Okay, now we'll see the actual devices on which we are going to work on. Okay, so these are the different devices we have in a network. Okay, just to we use these devices to make a network. Okay, so what are those? First one is what? Hub. Second one is repeater, bridge, switch, router, firewall, server, IP phone, wireless access points, wireless controller, and network interface card. Okay, so these are some different devices you are using in your network. Okay, the first one, hub. What exactly the hub is?
Connect different devices.
It's a layer 2 device. Okay.
Connect multiple devices.
Yeah, obviously. Obviously. Okay, then
Broadcast. Either collision. It broadcasts. You can collide.
Okay. It broadcasts the data packets. Okay, and then
No, we are not using. Not secure.
it's not secure.
Single broadcast.
Single broadcast domain. Okay. Then I can go for repeater then. Okay. The first one is hub. Okay. What exactly the hub is? It is a networking device which is used to connect two or more networking devices to make a communication possible. And it is common connection point where all devices connected to be in the network. Okay. What we do here? This is just a plug and play device. Okay, just to make those devices in a single network or a same network just to communicate with each other, we are going to use this hub device. Okay, yeah, that is true. We are not using this hub device nowadays because this has been replaced with a switch. Okay, so before switch, we used to use this hub device. Yes, why we used to use this one? Just to make some of the networking devices to make communication with each other. Okay, and to make them in a same network. Yes. So the hub has a numerous ports. If a packet or data reaches as any port of the device, it simply broadcasts the same packet to every port. That is what is called as what? Non-intelligent or dumb device. Okay. So let's suppose like we have a hub device like this. Okay, which is having some 4 ports. Let's suppose like some of the PCs are connected here. And when this PC1 wants to talk with the PC4, okay, so obviously it will go into, I mean, they are connected through this hub, right? Yes, obviously it is going to send that same packet towards the hub first. Yes, so what the hub will do? Hub says, I don't know where is this PC4 is. I don't know who is this PC4. Okay, what is my job is? Whatever the data packet I'm getting, I'm just going to distribute to everyone. That is their headache. Their headache means what? The end device's headache whether to take that packet or not. Okay. So what it will do? It will take that packet and copy that and send it to everyone. That's what the hub device job is. But what happens in the switch or router? They know how to send the data and where to send the data. Why? Because they maintain some tables. The switch maintains the MAC address table and this router maintains the routing table. Okay, because they can understand some addresses. Switch can understand MAC address and router can understand IP address. Okay, so based on that, it is going to maintain a table, and according to that table, the data packet will be forwarded. Okay, in switch, one port to other port, okay, based on the MAC address. In router, one network to another network. Okay, but this hub don't know what exactly the MAC address is, what exactly the IP address is. So that's the reason it is called as what? Non-intelligent or dumb device. It is not going to maintain any kind of topological information of its own network. Okay, whatever the devices which it is helping to make a communication, it don't know who are they. It is just kind of a, as I always said you, plug and play device. Okay, they will make these end devices to communicate with each other. That's it. Understood? I mean, at any time, at any port, okay, it is getting any kind of data packet. What it does, it will just broadcast it. Every time it does the same thing. Understood? So the first point, some of the important points of this hub, it is called as what? Yeah, already said you, non-intelligent or dumb device because it does not maintain any kind of a topological information. Okay. And then the second point is it has a single broadcast domain, and third point is it has a single collision domain. So what is a single broadcast domain? I already said you, if it is getting a data packet at any port, it will be broadcasting it to every other port, every other device which it is connected with. Okay, except where it got the data from. Okay, it is not going to send the same packet towards the same data, what do you call device. Okay, where it got from. Okay, other than that, except that device, it is going to forward the same data packet to everyone. Okay, that's the reason it is called as what? It is having a single broadcast domain. Okay, and if you compare this broadcast domain or collision domain with the switch or router, okay, they don't have this one. They have per port, say, broadcast domain and per port collision domain. What happens here? In the collision domain, if the collision is happening, okay, Let's suppose again we have the same 4-port hub device. Just an example. And if it is sending the data, okay, let's suppose the PC2 is sending the data, and at the same time, the PC3 also sending the data towards the PC4. Okay, so what happens? The data will be collided at some port. Okay, so what happens when the collision happens in this hub device? This collision is going to affect the whole device, not only that particular port where the collision happened. It is going to affect the whole device. So the whole device will be stop working for some minute. Okay, so after clearing the traffic, then again it will be start working as a hub device. Understood? So that's why they call it as it is having a single collision domain. Understood?
स्टॉप होता है फिर से स्टार्ट होता है फिर
फिर से मतलब
जो डाटा ट्रांसफर हो रहा है बीच में स्टॉप हो रहा है फिर स्टार्ट होता है
डिवाइस
लोग 5-10 मिनट के लिए वो स्टॉप होता
हाँ नॉट 5-10 मिनट
है
हाँ हाँ
तो फिर से वो स्टार्ट जीरो से करेगा
हाँ जो जहां से रुका था ना वहीं से करेगा
वही से
हाँ and the fourth point is it works on half duplex mode of communication. Okay, what do you mean by half duplex mode of communication?
मतलब वन अपना सिंगल टाइम सेम टाइम और टाइम रिप्लाई at a time.
It's also kind of a bidirectional communication, but one at a time. Okay, and it works at the physical layer. That is a layer 1 of OSI reference model. What did you say? What you said? Layer 2. No, it's not layer 2. It's a layer 1 device. It works in a physical layer. Okay. And on this hub device, we can't configure anything because it doesn't have any kind of memory to store anything. Okay. As if you see in the switch device or router device, they'll be having their own operating system. Okay. And they'll be having their flash memory, RAM, or something that. Okay. Just to store the configuration and the operating system. But this hub doesn't have those kind of things. So that's the reason we can't configure this hub device. Okay. So it doesn't support any kind of VLAN or spanning tree protocols. Yes. So this was about the hub. So how many layers are there in OSI reference model?
7.
7 layers. Can somebody tell me in order? Starting at the layer 7.
Physical layer.
Huh?
Sorry, application layer. Presentation layer, session layer, network layer, sorry, transmission layer,
Transport layer.
transport layer,
Hmm.
network layer,
Mhm.
link layer,
Mhm.
physical layer.
Which is layer 6.
The data link layer,
6.
data layer, the 6. Oh, presentation layer.
Okay. Yeah, though you write the layers like 7, 6, 5, 4 like this, but you should be aware like what is the number of that layer. Okay, which is the 7th layer? It's always application layer. Okay, though you write it like this, you may get confused like the 7th layer is what? Physical layer. No, 7th layer is always application layer. Okay, 6th is presentation, 5th is session, and after that 4th is transport, network, data link, and the physical. Okay, so this is how the order goes with the OSI reference model. Okay. So next devices are like repeater and bridge. So repeater, the name itself will tell you what it does. Okay. So it is also a networking device which is having only 2 ports. So its job is to generate or regenerate the signal for the same network before the signal gets corrupted or too weak, and it also amplifies the signal when the input signal is too weak and copies bit by bit to regenerate the data. Okay, so what is the maximum distance a LAN cable can transmit the data with the same strength? What is the maximum distance? After this distance, the strength of that data will be get weak. So what is that distances? 100 meter. Sure. Yes, Pardeep. 5 kilometer, no. It is 100 meter. Okay. So after 100 meter, what happens? The data will start to get lost. Okay. It will start to lose its strength. Okay. So that's the reason what we do. We connect a device in between from between the source and destination, we connect a device called repeater, and even we can use bridge also. So what they will do, they will just take this data, okay, they will just take this data bit by bit, okay, and they will regenerate the data. Okay, they will not or amplify. They will amplify the data and they will send it towards the destination. Okay, you can see here. This is the repeater. Okay, what it does? So this end is connected where the data is coming, okay, and this end is connected where the data is going, destination. Okay, so inside it goes and it will process it, it will regenerate the data, it will amplify the data, and it will send it towards the destination. Okay, and bridge will also do the same thing, but it can understand MAC address. Based on MAC address, it is going to filter out the data. Okay, so that's what the difference between we have in the repeater and bridge, but both does the same thing. And repeater works in the layer 1, physical layer. Okay, physical layer, the two devices works. One is a hub device and second one is a repeater. And in layer 2, the bridge and a switch. These two devices works. Layer 2 switch. Okay, so bridge, it is kind of a repeater which works in the second layer, and that is like a data link layer of the OSI reference model with some additional functionality of filtering the data by reading MAC addresses of the source and destination. Okay, so it has a single input and single output port, making it as a 2-port device. Same you can see here. So how many ports we have on this bridge? 2 ports. One is the input and second is the output. So input is coming from the source and output it's going towards the destination. So the same, it will do the same thing. Okay, but the extra additional functionality it is having, like it is going to filter out the data based on the MAC addresses. That's it. Okay, and it works at the layer 2. That's a data link layer of OSI model. Okay, so next we have a switch. Okay, a switch is a networking device which works at the data link layer, and it used to connect a different networking device in the same network. Okay, whenever they ask you what exactly the switch is, this is really important. What is a switch? Obviously, it is a networking device. We used to connect the different networking devices in a same network. And this device works in the layer 2. That is a data link layer. Understood? And it can perform error checking before forwarding the data, which makes it very efficient as it does not forward packets that have an error. While transmitting the data, an extra feature of this switch is what? Always it will find for the error. So based on some checksum value or algorithm, okay, what they will do? They will just find any error. Is it having in the error, having any kind of error in the data? Okay, if it is having any error, then immediately it will be sent towards the transport layer. Okay, this switch will notify the data. Okay, that will be detected and notified. So to which layer it will be notified? To the transport layer. Okay, what the transport layer will do? It will correct the data, correct the errors. Understood? So it is an intelligent device which has a topological information of the network. If you compare this switch with the hub doesn't maintain any kind of table. It don't know what exactly the topology I'm currently connected in. Okay. But when it comes to switch, it is having every information of its own topology. Okay. With the help of what? With the help of this table. The switch maintains the CAM or MAC address table just to make the communication possible. Both are same. Content addressable memory and media access control. This is a physical, okay, and this is logical. Whatever the MAC address table you can see inside that switch, that is called as what? Content addressable memory. This will be actually stored in the memory of that switch. Okay, and we call it as logically media access control. Okay, both are same. Understood? Next, switch works on full duplex mode of communication. That means it's a two-way communication or bidirectional communication simultaneously. Yes. So switches, yeah, this is important. Switches has one broadcast domain by default, but only for very first packet. After that, it will send all the unicast data packets. So what do you mean by this one? As I already said, you like switch and router doesn't have broadcast domain. Okay, they have per port broadcast domain, but switch has per packet. I mean, first packet broadcast. Okay, what it will do? As I already said you, this switch works on the MAC addresses. Okay, let's suppose like this is my switch. Okay, where I have connected some 4 PCs. And now this first PC wants to talk with the PC4. Okay, what the PCs will do? Obviously, they are going to give the source IP address, destination IP address, source MAC address, and the destination MAC address. Okay, and it is the first PCs know that like I just want to talk with the PC4. Okay, let's suppose like these are having the IP addresses like 10.1, 10.2, okay, and 10.3 and 10.4. Yes, so at the source IP address, it will be having the 10.1. At the destination, it will be having the 10.4. Okay, and source MAC address, let's say it is having A, B, C, and D. Okay, so what the PC1 will do? It will give its own MAC address as a source, and it says like, I don't know what is the PC4's MAC address. Okay, for that, what it will do? It will generate an extra packet. Okay, so it will just keep this communication packet on hold and it will generate a one more packet. We call it as a ARP packet. What? ARP, Address Resolution Protocol. Okay, the name itself will tell you what it is used for. It will give us a resolution on address, what we are finding. What address? Physical address, MAC address. Okay, so what the ARP will do? It will just broadcast the same packet what it is having. So it will go and ask, is there any device who is having 10.4 IP address? Okay, I want your MAC address. Somebody is asking for your MAC address. Can you just give me your MAC address? Because they just want to talk to you. Okay, in this case, 10.1 is the what you call source device. So 10.1 wants to communicate with you. Can you just give me a MAC address? It's just like what? Postmaster, I can say. Who will take your post and give it to the destination. Okay, and if there is any reply, he will take that and he will give it to you. That's what. Understood? So it is kind of what? A destination address where I can directly reach and talk to the destination device. Okay, to find that destination location, the ARP protocol will help us. Understood? Destination location means what? This physical address. I know the logical address. Logical address means what? It's the IP address. Okay, I know what his name is, but I don't know where he reside, where he live. Okay, just to know that one, where he live in my network, I'm taking the help of this postman. Okay, what the postman will do? He'll go to that location. I mean, just an example, not exactly the postman that do. Okay, so he'll go to the location and he'll know the location of that what do you call destination device, and he'll come back with an address. Okay, in this case, MAC address is the address. Okay, so initially the packet, okay, that will be broadcasted only for the first time. As I already said you, switch doesn't broadcast anything, but it will do it for just to know the MAC address. Okay, once it does know the MAC address, then every packet will be unicasted. What do you mean by unicast? It's again one-to-one communication. Broadcast means what? One to all. So initially it will send the same packet to everyone, and after knowing the MAC address, it will start the unicast communication. Understood? Sure? Okay. So switch has a per port collision domain. As I already said you, switch and both router. They have per port collision domain. That means it is not going to affect the whole device. It is going to affect only that particular port. Understood? So switch works in the data link layer, that is layer 2 of the OSI reference model. Okay, and these kind of the port numbers you can get in the market if you are going to buy the switch. Okay. Now we'll see the different types of the switches. So mainly when I explain these switches, I compare these two, and then only I'll able to explain this one. So if we just see the first two types, first one is a unmanaged switch and second one is a managed switch. Okay, what exactly this unmanaged and managed are? In simple words, unmanaged switches are just like the plug and play, but they can understand MAC address. But we can't configure those devices. We can't configure the unmanaged devices. But managed devices, they will allow us to configure the device. Understood? You can see here, these kind of switches have a simple plug and play design and do not offer advanced configuration. Yeah, yeah, you can. Yeah, I was saying like it will not offer any kind of advanced configuration option and which are only suitable for the small network. Okay, and like just an example, this is my switch. Okay, and this is kind of a unmanaged switch. I can't configure anything. I can't configure any VLANs on that one. I can't configure any port security on that one. I can't uh, aggregate the links on that one. Okay, these are some different switching protocols. What we do. Okay, so we can't do it on that switch. It's kind of for just a plug and play. So based on MAC address table, it is going to forward the data from one device to another device without knowing what is exactly the VLAN is, what exactly the link aggregation is, what exactly the port security is, okay, what exactly the quality of service is. You don't know anything. Okay, it will help us just to forward the data from one MAC address to another MAC address. So what is this managed switch? It will allow us to configure it. Okay, you can see here, this kind of switch offer advanced configuration options such as VLANs, quality of service, and link aggregation, and they are suitable for more complex network, which allows for centralized management. Okay, whatever the star topology you have seen yesterday, so we use the same managed switch. Yeah, you can use unmanaged switches also, but that will not allow any kind of configuration. But if you want any kind of security or a configuration, okay, you have to go for the managed switch. Okay, where it will allow us to configure the VLANs, It will allow us to configure the quality of service or port security or link aggregation, these kind of protocols. Understood? And even we can use this managed switch for the complex network. Okay, that is not possible with the unmanaged switch. Clear about these two? Sure. Next is layer 2 and layer 3 switch. As I already said you, switch works in which layer? Data link layer. Oh, what is this new thing? Layer 3 switch. They are saying like layer 3 also and switch also. What is this new thing? Any idea?
Find IP address also.
It finds IP address also. Okay. See, when you see the layer 2 switch, it works only in the data link layer. Okay, which can understand only MAC addresses, and based on this MAC address table, it is going to forward the data from one device to another device. But what happens in the layer 3? Okay, it will work as both. Both means what? Switch and as well as a router whenever you require. Okay, let's suppose like you're starting a company, okay, and you don't have that much of budget to buy a router. Okay, what you can do? You can buy a layer 3 switch, which will work you as a router and as well as a switch. Okay, it will works in the network layer. Layer 3 switch works in the network layer of the OSI reference model, which can send the data or route the data between the different segment. But when it comes to layer 2, it can send the or forward the data between the devices on the same network. Okay, and it works in the data link layer. So clear about what is the difference between layer 2 and layer 3? Layer 2 works only in the data link layer just to forward the data based on the MAC addresses. And layer 3, initially it works as a switch. And if you want it as a router, then you have to give a command. Okay, you have to say it as a IP routing. Then it will start behaving as a router. Clear? Understood? Good. Next is what? PoE, Power over Ethernet switch. So it's kind of a switch. Okay, can you see that camera? Okay, have you seen the IP cameras? IP cameras. Okay, so some of the cameras will be there like they will be having separate power source or power cable, and just to transfer the data, they will be having this Ethernet cable. Okay, but some of the cameras will be like they will be fetching or transferring the data and power from the same Ethernet cable. Okay, they will not use a separate power source or power cable. Okay, just to get the power. They will be getting the power from same switch or same cable through it is sending the data. Okay, so wherever it is getting the power, okay, that switch is called as what? PoE switch, power over Ethernet switch. Okay, you can see here it has a power over Ethernet capability which allows them to supply power to network devices over the same cable that carries the data. Okay, let's suppose like you are connected with a camera, okay, and through the Ethernet cable, and through the same you are sending the power to that camera. Obviously that camera need power, right, just to run and all. Okay, so to send the power, okay, you will be sending that power through the same Ethernet. But the thing is like to give the power through the same Ethernet cable, you have to connect it with the PoE switch. You can't connect to any unmanaged switch or a managed switch. They'll not allow you to send the power. They will allow only to transceive the data. Okay, but if you want the same cable should carry both power and data, then you have to connect it with you have to be connected with the what? Power over Ethernet switch. Okay, so these are some different types of the switches. Any doubt here? No? Online? Any doubt?
No, no doubts.
No, roaming or Ethernet switch.
We don't have it here. The lab you can find out. Okay. So till now I was saying that switch will understand MAC address based on the MAC address only. It will send the data. So what exactly this MAC address is now? Okay. So this MAC stands for what? Media access control. Yes. So it's a physical or a hardware address of a device. Yes. What it is? It's a physical or a hardware address. Like you have your name, Dhiresh. Okay. Whatever the name you have. Yes. I'm having Arun. So like this, every device they're having their address on their name. Okay. Based on that only, they will be recognized in the network. Understood? So that is called as what? Physical address or a hardware address. Yes. And the size of this MAC address is what? 48 bits. Remember this. What is the size of the MAC address? 48 bits. And this MAC address is represented in 12 hexadecimal numbers. Okay. Now tell me how many number system we have. How many number system we have? 4. What are those? First one is a decimal. Okay. Second one is a binary. And third one, octal. Fourth one is hexadecimal. Okay. So how many numbers we have in decimal? 0 to deci means what? Deci means what? Deci means 10, right? Okay. So total number we are having 10 here. That is 0 to 9. Okay. And second one is binary. Okay. Bi means what? Not by, bi, not by. Okay. It is 2. Okay. 0 and 1. And third one, we have octal. What do you mean by octal? 8 numbers, that is 0 to 7. Okay. And last one, that is hexadecimal. What is hex? Hex. 6. Deci. Total 16. That is 0 to 15. Okay. And we write the IP addresses in decimal number. Okay. And we write the MAC address in hexadecimal number. Understood? So hexadecimal. So how they write these numbers? Normal like 0 to 15? No, they'll not write like that. Okay. They'll write it like 0 to 9 as a normal numbers. After that, whatever the 10, 11, 12, 13, 14, and 15. They're going to write it as a alphabets. Okay. That is A, B, C, D, E, and F. Okay. Which is the last number? 15. And they write it as a F. Remember this F. Why? I'll tell it later. Understood? So what is the size of this MAC address now? 48 bits. Okay. And a MAC address is called as what? Physical address in PC or laptop and are separated by hyphen. I'll show you. Okay. In mobiles, it is called as what? Hardware address and separated by a colon. And the Cisco device, they'll not call it as a MAC address. Okay, they call it as a BIA, burnt in address. Okay, and here the segments are separated by a dot. Okay, now everybody open your mobile and just try to check what MAC address you are having. Are you all having the same MAC address or what? Okay, and how it is separated. You found it? No? Yeah. Will not be having a device's MAC address. Whatever the network you are connected with, so that adapter MAC address will be having. Okay. Okay, I just wanted to show you that like how it is separated. Separated by colon. Yes. Found it, everyone? And do you all have the same MAC address? On your mobile, do you all having the same MAC address? No, right? It is not possible. Okay, because in the whole world, your device is unique. Understood? Now we can see here. This is my system's MAC address. Okay, 20-7B-D5-1A-0E-58. Okay, how it is separated? Separated via hyphen. And you can find both here. Both means alphanumeric. It's a alphanumeric number. Okay, it is having both alphabets and the numbers. We call it as a hexadecimal numbers. Okay, how many segments you can find here? How many segments? So this is 1, 2, 3, 4, 5, 6. Okay, in a single segment, we'll be having two numbers. Two numbers. Okay, so each number is having a size of, you can see here. So 27B, okay, D5 hyphen 1A 0E and 58. This is what the number what we have. Okay. So if you help me with the conversion here, I just want to convert this hexadecimal number into binary number. How to do that? What is the binary number of 2? Huh? hexadecimal to binary. See, when it comes to octal, okay, you will have only 3 bits. When it comes to the hexadecimal, you'll get 4 bits. I hope you remember 8421 rule. Do you know? Or it's new for you? New? Totally? Okay, I want 2 now. Okay, this is my rule. I want 2. Okay, which bit should be high? Third bit. Okay, 0, 0, 1, 0. This is a binary number. Okay, for 2, 0, 0, 1, 0. And for 0, all zeros. Okay, now for 7, 0, 1, 1, 1. Okay, 0, 1, 1, 1. And for B, first tell me what do you mean by B? 11, right? So now tell me the number. 1, 0, 1, 1. 8 plus 2 plus 1, 11. Understood? How to convert from hexadecimal number to binary number. It will help you in subnetting. So that's the reason I explained it here. Okay. You can see here now. It was like 1011, right? Yeah. So in a single segment, how many binary bits we have? Huh? 8, right? 8 bits. So how many segments we have like here? 6. Okay. If you are really good at mathematics, 48 bits. So what I said, what is the size of the MAC address? You found that one? Yes? Is that right? Did you get it? So all these are like 12 hexadecimal number. Okay. What I mentioned, this MAC address is represented in 12 hexadecimal number. Same 12 hexadecimal number you can see on your system also. On your mobile also you saw the 12 numbers only. Yes? Was what like is it like the 13 numbers or 14 numbers? No. Exactly, you'll be having a 12 hexadecimal number. Okay. So here also you found the same thing. 6 segments. In each segment, you will be having a 2 numbers. So obviously it will be a 12 hexadecimal number. Okay. And each segment is having a size of 8 bits. Like that, how many segments we have? 6 segments. So total it will be making it as a 48 bits. Am I clear? Sure? Okay. Yeah. This is called as what? Physical address. You can see here. Physical address. Okay. On both PC and laptop, it is called as what? Physical address, and they're separated by a hyphen. And in mobile, it is called as what? Hardware address, and they're separated by colon. And in Cisco, they call it as a BIA, burnt in address. Okay. And they are separated by a dot. Okay. Just show you. Can you see the MAC addresses there at the end? Yes, how they're separated? Dot. Okay, and the last, whatever the last one you can see, VLAN 1. The last one. Okay, this is the actual MAC address of this switch. Okay, so here the switches will be having separate interface MAC address also and the whole device MAC address also. Okay, the last one is a device MAC address. Okay, you can see here base Ethernet MAC address. Okay, that is having 0009 7C B3 D059. Same you can see here D059. Is that same? Understood? This is how to find the MAC address or base MAC address of the device. Okay. Okay. The fifth one is like in any MAC address, the first 6 hexadecimal numbers are provided by the INA. That is Internet Assigned Number Authority. It's an authority that will give you or provide you the MAC address and the IP addresses initially. Okay. The first 6 hexadecimal number, they are provided by the authority, that is INA. Okay. And the next 6 hexadecimal numbers are provided by the vendors who are manufacturing the device. Okay. So the manufacturer is going to decide the next 6 hexadecimal number. The first range they will be given by the INA authority. Okay. And after this, remaining 6 will be decided by the manufacturer. Okay. And in a PC device, its MAC addresses depends on their NIC, network interface card, and your system also. Okay. Can you find different MAC addresses here? Physical address. What is this? 27B D5. Okay, here it is something different. Why? This is Ethernet adapter 1 and this is Ethernet adapter virtual Ethernet. Okay, now I have connected with the wireless one. Okay, you can see here. This is having some different MAC address. This is having some different MAC address. Okay, so our system don't have its own MAC address. It really depends on the NIC what you are connected with. NIC means what? Network interface card. It may be wired one or it may be wireless one. Okay, each having a different MAC address because anyway we are going to find the MAC address only, right? Based on the network. Okay, so that's the reason we give the MAC address to the network interface card, not to the device. Understood? Okay, next we have that is a router. So what exactly the router is? It is a networking device which routes the data packets based on the IP address and it makes the communication established between different network. As I already said you, router works on the IP addresses and it will find the best path with the help of routing table. Okay, and it will allow us to make the communication between the networks, not in the same network, in the different network. Okay, and this like a routers every port, okay, which works on the full duplex mode. That means bidirectional communication simultaneously. Okay, and it has a port broadcast and collision domain. I said you right. Router doesn't broadcast any packet to the different network. Yes, in the same network it does, but to the different network it will not. Then what is the what do you call? If it start to broadcast the packets, then what is the security? What is the privacy? Yes, so that's the reason router doesn't broadcast anything. Okay, and it is also having what? Per port collision domain. Even the collision is happening, it is not going to affect the other port. It will be affect only that particular port where the collision happened. Yeah. And the router works in network layer. That is a layer 3 of the OSI reference model. Where it works? It works in the network layer. That's a layer 3 of the OSI model. Yes. And the maximum number of ports on a single router device we can get is a 8 ports. Yes, so we can add some more ports with a add-on cards. Okay, but initially they will become coming with a maximum 8 ports. Okay, how many ports we can find here? Only 2. Okay, these are there. Yes. Next we are having NIC. What is NIC? Network Interface Card. So NIC is a network adapter that is used to connect the computer to the network, and it is installed in the computer which establish a LAN, and this card is it's having its own unique ID or MAC address. So what the NIC will do? It will allow us like our laptop or a PC device to connect to the network. It may be wired one or it may be wireless one. Okay, and they are having their own unique ID. We call it as a MAC address. And this is also called as what? Network adapter, LAN adapter, or physical network interface. Okay, so they are integrated within the motherboard. Okay. If you want to add, yeah, you will be having an extra slot for that also on the motherboard. Okay, next, what is firewall? Any idea? Protection, okay.
Blocking the threats,
Mm-hmm.
filtering input and output traffic
Okay,
to prioritize.
okay. Okay, if you want the exact definition, yes, it is a security device. Okay, a firewall is a security device or a software that monitors and controls the incoming and outgoing network traffic based on some predefined security rules. Whatever the policies you are given, whatever the predefined rules you have applied on that one, so based on that, it is going to monitor and filter out the data. Okay, which may be incoming to the router. Okay, sorry, incoming to the network or outgoing to the of the network. Okay, so everything will be monitored and that will be compared against that security rules what we have given that. Okay. So firewalls are essential components in the network security, acting as a barrier between trusted internal network and the untrusted external network, just like the internet. Okay, so obviously you know that which is trusted one and which is untrusted one. Our internal network will be what? A secured network. Okay, and we don't want anybody just intrude into our secured network. Okay, so how to stop this one? We'll be having a firewall in between. In between what? In between the untrusted network to the trusted network. Okay, so it will be what it will be doing. So based on that predefined rules, it will be monitoring and filtering out the data which is coming from untrusted network to the into the trusted network. Okay. So it will help us to like network protection and traffic monitoring and policy enforcement, like protection against malware, and even it will help us for the VPN. Okay. Next, we are having a server. So what is server? Story. Okay. Mm-hmm. Okay. See, server here also name itself will tell you. It is going to serve the different device. If I'm asking something, okay, if you're having that data, so you'll help me. serving, server. Okay. So server is a specialized computer or a system that provides the services, resources, or data to the other computers over the network. Okay, which will help us like resource sharing or centralized management or data storage and backup, application hosting or scalability. Okay, so these are what the server is. Next, we are having wireless access point. So what is that wireless access point? WAP. So what is this wireless access point? It's a networking device that helps to connect a wireless device to the wired network using some Bluetooth or Wi-Fi or radio waves. You can see here. Here I have connected a wireless access point where these wireless clients are connected, not through wired, through wireless. Okay. And they're able to communicate with the wired network. You can see here, these PCs are connected to the network via a channel, a wire. Okay. But these are connected via wireless. So, but still they are able to communicate with each other through this wireless access point. So what is this wireless access point? This is a kind of a device which will help the wireless clients to communicate with the wired network. Okay, with the help of this Bluetooth or Wi-Fi or a radio waves. Okay. So WAPs will helps to provide the connectivity to the devices like laptop, smartphone, tablet, and even the IoT devices to access the network or internet without using any kind of a physical cable or a media. Okay, so they are also used as a network extension devices to transmit the data from wireless network to the wired network. Okay, so we'll be using it to make the communication between wireless media to the wired media. Clear? And to control these all, we'll be having a controller. We call it as a wireless controller, WLAN controller. Okay, so what is this now? It's a centralized controller. It's a specialized device used in a enterprise wireless network to manage and control multiple access points. Okay, let's suppose we have a campus. So in that we have some 30 to 50 access points. We have a big campus of it may be a company or maybe a college or something. So where we have some 30 to 50 access point, and it is not that easy to control all of them individually. Okay, so that's the reason what we'll do. We'll just take a centralized controller just to make or take them under our control. Okay, for example, if you want to change any kind of configuration, what you have to do? You have to go to each and every, what do you call it, access point, just to change that particular configuration. But what if it is connected to the centralized controller? Just hitting, typing the change and just hitting enter, that will be broadcasted to all the access point. That means at the same time, the configuration will be changed on all the 50 APs. Okay, so that's why we use this WLAN controller. Understood? So it is a it centralizes the configuration, monitoring, and management of the wireless network, simplifying the deployment and maintenance of the large-scale Wi-Fi network. Understood? So these are the different networking devices we use in the network. Clear? Any doubt? Yes? Any doubt? Sure. Now just be honest, how many of you are sleeping? I know who is sleeping. Yes, online. Any question in the devices?
I'm okay. Thank you.
Gopala Krishna, Prateek, Vaishnav.
All good.
Okay. Yeah. Next topic is Ethernet. Okay, what is this Ethernet? It's kind of a technology or network technology that includes a protocol, port, cables, and chips needed to plug into the local area network for data transmission using a coaxial or a twisted pair cable or fiber optic cable. Okay, what is this? This is kind of a technology that we use with the cables. Okay, so it is mostly of the speed. It is mostly of speed, data transmission speed. In this, you can find how what protocol it is supporting, what kind of port it is, and in which on which sorry by using which cable we can transmit this much of speed. Okay, so that will be decided here. Yes, in that one we'll be having some four types. First one is a standard Ethernet, that is also called as what, IEEE 802.3. Okay, which is having the data transmission speed up to 10 Mbps. Okay, second one is the fast Ethernet. It's also called as what, IEEE 802.3U, and the maximum data transmission speed is 100 Mbps. And the third one is a gigabit Ethernet. It is also called as what, IEEE 802.3Z. Okay, the maximum data speed is up to 1000 Gbps or a 1000 Mbps or a 1 Gbps. And the last one is a 10 gigabit Ethernet, IEEE 802.3AE. Okay, where the data speed is what, 10 Gbps. Okay. Can you find the ports there? Yes, what it is written? Is it a fast Ethernet? On port it will be written FE 0/1/0/0 is there, right? FE means what? It is a fast Ethernet. Okay, that means those ports can able to send the data up to 100 Mbps maximum. Okay, like that we will be having gigabit Ethernet, like that we will be having 10 gigabit Ethernet also. Okay, that will be mentioned on those devices. In that first one, standard Ethernet. Okay, yeah, it is already also called as what, IEEE 802.3, and which supports the maximum data speed up to 10 Mbps. So here we have some types. So we have four types here. Okay, so all are sending the data up to 10 Mbps with the baseband transmission, all the same. Okay, and that first one is a 10 base 5. 10 base 5 means what? 10 base 5. Okay, 10 means what? 10 Mbps. Base means what? Baseband transmission. And here in this 5 means what? 500 meter. Okay, so which can transmit the data up to 10 Mbps with a baseband transmission through a coaxial cable. Okay, up to 500 meter, which is used in the bus topology. Okay, so here you don't need to remember all these types. You need to remember only those four main types: standard, fast Ethernet, gigabit Ethernet, and the 10 gigabit Ethernet, and their data transmission speed. Okay. So second one is the 10 base 2, that is also called as what? Thin Ethernet, where it's going to use coaxial cable only for 200 meter. Okay. Again, it is used in the bus topology. And 10 base T means what? It's also called as what? Twisted pair cable. Sorry, twisted pair Ethernet. Okay, where it is using twisted pair cable up to 100 meter, and which is used in the star topology. And here 10 base F means what? F stands for a fiber optic. That is why it is also called as what? Fiber Ethernet. Yes. Here using fiber optic cable up to 2000 meter. Okay, and also used in again star topology. Yes. So second one is what? Fast Ethernet. It is also called as what? IEEE 802.3U, which supports the maximum data speed up to 100 Mbps. So here the first type is what? 100 base TX. Okay. TX means what? It's a twisted pair cable. Yes, up to 100 meter, and which may be using category 5 STP or UTP. What do you mean by STP or UTP? Yeah, obviously they are twisted pair cable. कोई वर्ड फिट होता है क्या देखो. Yesterday only studied about this. STP, UTP, yeah. Shielded and unshielded paper.
Twisted cables and unshielded.
Exactly. Okay, in twisted pair cable, we have some category, starting with category 1 to category 10. Okay, again, they are based on the transmission speed, what they have. Okay, so here in this 10 base, sorry, 100 base TX, it is going to use category 5 STP or UTP type of a twisted pair cable. Okay, 100 base FX means what? It's going to use a fiber optic cable up to 100 meter. Okay, and 100 base T4 means what? Again, it is using the twisted pair cable up to 100 meter, and this time it is a category 4 UTP. Okay, so these are the three types in the fast Ethernet. Next we have gigabit Ethernet. So also known as what? IEEE 802.3Z, which supports the maximum data speed up to 1000 Mbps or a 1 Gbps. Okay, here we have four types again: 1000 base XS, SX, 1000 base LX, 1000 base CX, and 1000 base T. Where S stands for what? Short distance, short wavelength. Okay, where all these types uses a fiber optic cable. Okay, but in this case, I mean CX and T, it uses a twisted pair cable just for the short distance communication. Okay, so here SX means what? It will be using the optical fiber cable up to 550 meter. Okay, and 100 base LX means what? Here also it will be using the fiber optic cable for 5000 meter for the long distance and for the long wavelength. And CX means what? It's a cable. Which cable? Twisted pair cable up to 25 meter, and it uses STP type of twisted pair cable. And T means what? Twisted pair cable with only up to 25 meter. Here it uses category 5 UTP type. Understood? And the last one is 10 gigabit Ethernet. It is also called as what? IEEE 802.3E, which supports the maximum data speed up to 10 Gbps. Okay, here also we have some three types: 10 Gbps yes, 10 Gbps L, and 10 Gbps E. Okay, yes, short distance, short wavelength; L, short distance, sorry, long distance, long wavelength; and E means what? It's an extended version of the 10 Gbps L. Okay, where the S is starting, I mean, all are using the optic fiber cable. Okay, 10 Gbps S, it will be sending the data up to 300 meter. 10 Gbps L, it will be sending the data up to 10 kilometers, and 10 Gbps E, that will be sending the data up to 40 kilometers. Okay, so these are some different types of the Ethernet. Understood? Is that clear? Okay, next topic is OSI reference model. Still we have more than 35 minutes. Okay, we'll start this one. Yes. So what is OSI? What is OSI? Open system. Okay, what is that? Based on how to work. Mhm.
How to travel.
Does anybody know like why it is called as a reference model? Any idea? Why this OSI model is called as reference model? Do they don't use it in actually? They do? Why it is called reference?
Yeah, complex.
Mm-hmm.
Make, and it only transfer to that.
So for your information, for your kind information, before this OSI reference model, we had this TCP/IP model. Then why this OSI model?
And
So you think encryption will not happen in TCP/IP?
not that time of not
Okay.
some complex sharing data, not supporting, but devices not supporting,
Mm-hmm. Okay.
all devices not supporting. Making
Yeah.
some complex network.
Exactly. So OSI, Open System Interconnection. Okay. This is a reference model. Why? If you go into the history of this model, okay, it may be TCP or OSI. Okay. Initially, like when we started using the computers, okay. So which was the first vendor or manufacturer who started manufacturing this computer? It was IBM, obviously. What they have done, they just designed their own network part. They just designed their own network. Okay. And even other vendors also there, not only IBM. Okay. Other vendors also there. And they also designed their own network part. When they tried to make the communication between two IBM devices, that was able to possible. That was able to make the communication because both network systems design was same. Okay. But when they try to make the communication between different vendor, that was not possible. And it is not like everybody who in the whole world they are going to buy the IBM system only. It's not like that, right? You'll go for any other vendors also. Yes, but the communication is really important. Yes, so let's say if I'm having two companies, okay, company A and company B. In company A, I'm using IBM systems, and in company B, I'm using TechNet Solution systems. And these both companies are mine. Yes, obviously I'm going to exchange some data between these two, but this is not possible because the network design what I have on these two, okay, they are different. It is not allowing us to exchange the data packets. Understood? So that's the reason what the vendors they have done, they just went to this ISO, International Organization of Standardization. So this is what the problem we are facing. Okay, so please help with this and solution. Okay, so what the ISO done? They found one agency and they asked them to find a reference model. Find a reference model. That model should be referred by every vendor while they are designing their network part. Okay, just to make this model as a standardized model that should be taken by all the vendors. Okay, so that's the reason this OSI model is called as what? OSI reference model. Understood? Clear? Yeah, history, when the network first came into the action, computers could typically communicate only with the same manufacturers or a vendor. Okay, for example, companies like a DECnet solution or IBM solution never communicate with each other, but they were because they were manufactured by the different vendor, but with the same they could. So to come out of this barrier, ISO, International Organization of Standardization, they created a reference model called OSI, Open System Interconnection. It is open for everyone, okay, just to make the interconnection, just to make the communication. Okay, I don't know the exact year, so in the late 1970s you can see. Okay, so this OSI model was meant to help different vendors to create interoperable network devices and software in the form of protocols, so that different vendor network devices could communicate with each other. Okay, this was a main motto behind this OSI reference model, just to make the inter-vendor communication, just to make the communication between the vendors. Okay, so what exactly the advantages we have by having this OSI reference model? The first one is like it divides the network communication process into smaller and simpler components, facilitating components development, design, and troubleshooting. Okay, so what it does, it is going to break the whole communication part in a simple parts. You can see there some 7 layers are there, and each layer they're having their own job to do. Application layer is having some different job, presentation layer is having some different job. Okay, so like this, transport is having something different, network is having something different, data link is having something different jobs to do. Okay, like this, they have just divided this whole communication into some simpler formats. Okay, this was the first advantage. And second one is what? It allows multiple vendors. It allows multiple vendor to develop through the standardization of the network components. So they'll take this particular OSI reference model as a standard model, and they will be able to develop their own network design. Okay. After that, it increases industry standardization by clearly defining what function occurs at each layer of the model. Obviously, this same thing I said you. Okay, so it's kind of a standardized model, and that should be taken from each and every vendor, taken by the each and every vendor. Okay, and there we already defined what is the job of this particular layer, and the same thing you have to take in your system. Okay, and it allows various types of network hardware and software to communicate with each other, and it prevents the changes in one layer from affecting the other layer. For example, if you are having any kind of a issue in one layer, okay, and that is not going to be affecting the other layer. Yes, so this is what the advantages of this OSI reference model. Okay, and you already know that how many layers we have? 7 layers. Okay, so those 7 layers, they are divided into again 2 groups. Okay, the first 3 layers what we have, that is application layer, presentation layer, and the session layer, we call it as a upper layers. Okay, the job is something different here in these 3 layers. Okay, and the remaining 4 layers, that is transport layer, network layer, data link layer, and the physical layer. Here the data transmission will be something different. Okay, these 2 upper layers and the bottom layer, they are totally different. The upper layer don't know what is happening in the bottom layer, and the bottom layers don't know what is happening in the upper layers. Understood? So OSI reference model has 7 different layers, and they are divided into 2 groups. The top 3 layers define how the application within the end station will communicate with each other as well as with the users, and the bottom 4 layers define how the data is transmitted end to end. Okay, so what is happening? If I'm talking with my laptop, it is all because of these three first upper layers. Okay, application layer is giving me the user interface, and presentation layer is presenting the data, whatever the format I want. Okay, that will be presented by the presentation layer. And the session layer, whatever the application I have opened here, like Cisco Packet Tracer, Paint, and the PPT and the Zoom. For each and every application, that will be maintaining the session, keeping the separate data. Okay, this is all happening inside. Understood? And the next four layers, they'll be allowing me to communicate with the online people. Okay, they are making the communication end to end with this Zoom application. So the first three layers, they don't know who is this transport layer, who is the network layer, who is the data link layer, who is the physical layer. They are doing just their job. What is our job? Our job is to give the user interface to the user. Okay, user means what? Like us. And how the user wants the data should be presented. Okay, that is the responsibility of the presentation layer. And for each and every application, the session will be maintained. Once he open that application until he ends that. Okay, whatever the data will be there, okay, that will be kept separate by the session layer. Okay, so these are the three upper layers. They don't know who is IP address, who is MAC address. That is a headache of the bottom layers. Okay. So application layer, it provides a user interface, and presentation layer, it presents the data, handle encryption, decryption, encoding, decoding, compression, and the decompression. So all these functions which happens at the presentation layer. And the session layer, it keeps different application data separate and controls the dialogue. Dialogue means what? Again, the session. Okay. So user will interact with the computer at the application layer, and also upper layers are responsible for what? Application communication between the host. So none of the application layer knows anything about networking or network addresses, because it is a responsibility of the bottom four layers. Okay, what happens with the upper layers? This is where the user will communicate with the system. Okay, this is where he is going to get the data in the required format. So that's the reason this upper layers, they don't know what exactly the networking is, what exactly the IP address is, because that is the responsibility of the bottom four layers. Okay, so now the bottom four layers, in that first one, transport layer, where it provides the reliable and unreliable delivery of the data and performs the error correction before the retransmission. As I already said, you right, error detection will be done by the data link layer. Okay, and error correction will be done by the transport layer. Okay, and the transport layer will give or provides a reliable or unreliable data delivery. Yes, with the help of two protocols, TCP and UDP. That we are going to learn it tomorrow. Next is network layer. It provides a logical addressing which routers use for the path selection. I hope you already know that. In this layer only, router works with the help of IP addresses. So with the help of that IP address, it is going to find the best path to reach the destination. Okay. Next is data link layer. It combines the packets into bytes and bytes into frames and provides the access to media access control. Okay, or media MAC address, and also performs the error detection, not correction. Okay, and the last one is a physical layer, where it converts the frames into bits and helps to connect to the other devices. Okay, so these are the different four layers which comes under the bottom layer. Okay, where the bottom layer defines how the data is transferred through physical media like wired or wireless. They are determine how to rebuild the data stream from transmitting source to destination. Okay, I mean how the data will be transmitted from source to destination, and once it reaches the destination, how to rebuild the data, because the data will be sent in the form of what? Electrical signal, okay, or light signal, or the wireless media. Okay, once it reaches the destination, it is going to rebuild it. I mean, it have to convert those electrical signals into bits, and bits into frames into packets, and packets into segments, and segments into data. Okay. Yeah, these are the 7 layers what we have. And remember this, tomorrow we're gonna see like how the data will be flowing in each and every layer here. Okay. So just remember this, the 7 layers of the OSI reference model and their PDU, protocol data unit. Protocol data unit means what? It's a collective data which is getting generated at each and every layer. Okay. So we call it is with a name. Okay. The first upper layer data or PDU is called as what? Same data only. Okay. When it comes to transport layer, we call it the PD of that is the segment, network layer, packets, data link layer, frames, and then the physical layer, it's a bits. Okay. And if you want to remember, I mean, it is really difficult to remember these layers in order. You can have this mnemonic. All people seems to need data processing, where A means what? Application. P means what? Presentation, session, transport, network, data link layer, and the physical layer. Okay. Understood. Okay, online. Any question?
No, I'm okay. Thank you.
Okay, then if you don't have any question, we'll continue the same thing tomorrow. Okay.